technology involved in it. It's not a hydraulic fracturing technology, which has been around since the 50s. Hydrofracking, they call it, right? Has nothing to do with horizontal drilling technology. That's also was around in the 1950s. But what it does have to do is the application of both hydrofracking and horizontal drilling technology to shale strata to exploit these natural fractures that previously had been overlooked. That's what is driving the entire shale oil boom today. And it's a boom. It really is happening, you know. Okay. And then shales such as the Marcellus are particularly well suited because the natural hydrofractures already exist in the formation, hundreds of which can be penetrated in a single horizontal wellbore. So it goes like this. So, and if anybody's interested, you can watch informative little video clips on YouTube on this kind of thing. We won't do that. So conventional oil and gas exploration, this is how it used to be for most of your natural oil, for exploring for oil and gas. You have what is called a source rock. Usually it's a black shale down here that's feeding it all. All of your for, you know, the whole oil and gas industry in the U.S. has been fed by this. And usually there's a porous sandstone layer where the gas of the oil percolates up into it, which gets cooked at pressure and temperature, and then mobilizes as oil and gas and forms into a trap, and they explore for the traps. That's the way it used to be done. Today, what's going on now? They're going straight to the source. They're going for the shale, the black shale, to using this technology to exploit the black shale. And guess what? It's working. Right? And ask people in North Dakota, they'll tell you how it's working. Right? By the time the well is hydrofracted, at least, now this is just some safety concerns here. A lot of people don't know anything about how a well is drilled. You start out with a big drill bit, usually about a couple feet across. That only goes down about 100 feet. And then what do? They run steel casing down there, and they pump concrete down the casing and up the walls to isolate the rock. So all of your fresh groundwater zones up here, there's steel and concrete separating any fluids in the borehole from the groundwater. You're isolating that, and then you're testing it, usually with state supervision. And then what happens? You go with a slightly smaller drill bit, you go down another few thousand feet, run casing, concrete up the sides again. You do this about 5 times before you reach the total depth of the borehole. Right? In other words, the whole thing is steel and concrete. There's no way it's going to leak anything, any of those fluids into the water column. Anybody who's done anything in oil and gas knows that this is the way it's done. It's been done. It's always been done this way, and it makes it safe for people who have water wells and so on. So this is the picture here. This is, you know, cement and steel. They, concerns that operators, oil and gas companies, fail to take proper precautions to protect groundwater aquifers are unfounded. This has been successfully met for a very long time. There's nothing new here, right? It's not difficult to do. Objective in horizontal drilling is you drill downward, and then they have this amazing technology where they can kick the borehole out and go sideways, right? And actually penetrate these vertical fractures. And then they blast holes through the pipe, because they run casing. The whole hole is cased with steel and concrete, right? All the way down to here. And then they blast holes through that steel and concrete with powerful explosives to produce whatever fluids are in that rock. They want it to flow into the rock. Right. And then do one more thing. They penetrate those fractures, and then they artificially widen and prop open those fractures using what's called hydraulic fracturing, where they pump under enormous pressure sand and water mixtures with some chemicals in it into the rock under enormous pressure to break the rock down so it gives up its fluids more easily. That's the idea. Okay, so all kinds of hype about hydrofracking, including Yoko Ono, Artists Against Fracking, you know, all these concerned people on TV, and you know, these kind of frightful looking things like this, you know, and lighting up. Look at this. In Pennsylvania, there have been natural gas seeps that have been seeping natural gas for centuries, right? And everybody who lives there knows they were always there. And now they say, now it makes all the news media stuff, because look at this, you can light a match this stuff, it's the oil companies, they're not telling us this, they're the ones that are doing this. It's been that way for centuries, right? Same thing with this one lighting up the tap water coming out of that. There are actually people who have homes out there where there is natural gas that seeps into their groundwater wells. It's been happening they know all about this. Nothing new. But now they're trying to bring lawsuits against the oil companies, and none of them have been successful. It's all a joke. But it really makes the presses run in the environmentalists, So what I'm saying is that an awful lot of this hype is irrational. There's not a good basis for it. But it's kind of spooky to see this kind of mob type of mentality of stop the fracking, we gotta preserve the environment, I like the environment too.
Yeah.
Okay, so what are the environmental risks here? Let's look at them. Let's look at them individually. Number one, contamination of freshwater aquifers. Number two, water demands. It takes a lot of water to do each well. Number three, wastewater treatment handling. We're gonna go through these quick, then ordinary footprint issues, such as building of roads and drilling pads and all that, which is, any oil industry has always had that. Aquifer contamination, this is considered the biggest risk. The aquifer is a water reservoir, right? Drinking water supply. All right. There's a fear that chemicals from the well bore is going to leak into that, right? Possible sources of contamination. You can go through each one of these things, and you can see that they're largely unfounded. Right? That's my point, and I'm not going to belabor these things too much, but and you can monitor this, and it is monitored very safely in Pennsylvania today, in North Dakota, and so on. What is the composition? A lot is made to do of these toxic chemicals in the hydrofracking fluids that mixes with the sand to prop open the cracks in the rock when they pour it in. This is a list of some of the materials. It requires a lot of water, sand, there's friction reducers, there's biocides to kill bacteria in there, there's acids, a couple things in there. And the thing to note is the most toxic components are present in extremely dilute quantities. In other words, you could fill a swimming pool with this stuff and probably go swimming in it, it wouldn't hurt you at all, right? There's nothing that dangerous about most of this stuff. Now there's some that are nasty. These are, this lists some of them too, by the way. Diluted acid, no different than the concentration you put in your swimming pool. Biocide, you use this to clean your sink with, same stuff. Stuff that's used in pharmaceuticals, laundry detergent. In other words, these are normal household chemicals. A lot of this stuff, there's nothing that bad. Now there's a few. Other chemicals not mentioned on this list include benzene. Now that's poisonous stuff. That's toxic, right? And it's present in diesel fuel, for example. Right? And formaldehyde, which we call embalming fluid. A little bit of that in there too, right? Although those things are toxic, if you've swallowed them in straight concentration, it can kill you, right? At the levels of dilution, when they have 5 or 6 million gallons of water and a little bit of that stuff in it, it's not the doomsday scenario they make it out to be. Yes, it's toxic. Yes, you don't want to mess with it, but it's so isolated, it's so dilute. The risk to anything, harming anybody is just, to me, it's almost zero, right? Demands placed on local fresh water sources. They say, well, if you're going to use 5 million gallons of water to frack one well, our creeks are going to run dry. Well, guess what? There's so much demand for this now. There's more and more companies popping up. There's service companies that recycle the water. We'll capture that water from the well that's just been fracked. As it begins to produce, once it produces the oil and gas, water comes up with it, right? They capture that water, recycle it, use it on the next one. So they're not expending vast amounts of water in these things, right? That's not a serious concern. Safe handling of wastewater from frack operations. This is a matter of plumbing. You can do this. Number one, it's not that toxic. Number two, under the right supervision, the right kind of maintenance, it's not that hard to do, right? We can do this. If we can land a man on the moon, we can do this, right? Footprint issues, the same as I mentioned before. What are the significant environmental risks? Contamination of fresh water, aquifers, water demands, wastewater, all these things. You can answer them. It's not that difficult to see through this, right? What are the opportunities in exploiting these things? Our economy can use it. Putting people to work would be a nice thing, right? That's one reason. The second reason, develop a natural resource that can serve as a bridge. We need a bridge between the time when we're ready to shift to alternative sources and now, when we're not ready. We need a supply, right?
Yeah.
If we're gonna think rationally. It's nice to talk about solar energy. I love this stuff. But you're not gonna power a jetliner with solar power,
No,
right? It's just not gonna happen.
no.
You know what I mean?
Fly in the daytime.
Right.
Oh.
Flying what?
Fly in the daytime.
Oh.
Flying, yeah, I mean, yeah.
Don't turn the panel away
At
from the
30 miles
sun.
an hour.
Yeah, it'd cover the, the thing would be filthy with panels, and have 20-mile wings, Okay, so,
Very stealthy.
imagine the airports, you'd have to use the landing thing. Proven Marcellus gas reserves alone may very well be God's provision for us as a nation. We may have like 7 prosperous years, and the 7 lean years to follow, like in the book of, it's in Genesis, isn't it? Or Exodus, yeah. It's in Genesis, isn't it?
Yeah.
Yeah, right. Yeah. And then, with a modicum of discretion and caution, these opportunities can be easily realized, right? So this was selected from a presentation I prepared for upstate New York, right? Tremendous challenges, right? Pennsylvania is really leading the way right now. Pennsylvania is prospering because of the Marcellus shale, right? New York, it's forbidden. Off limits, totally. And New York's economy is kind of floundering, right? Pennsylvania, people are getting rich, and everybody's working. People are happy, right? Same's going on in North Dakota, Texas, all around. So steps in helping a child overcome fears of the boogeyman in the closet. Number 1, you turn the light on. Number 2, you take the child by the hand to the closet. Number 3, have her look inside. Look at it. Look at the facts, will you?
Yeah.
Before you get emotional, let's look at the facts.
Yeah.
This isn't rocket science to exploit these reservoirs we got, right? Safely, environmentally, consciously, and all that. Okay, so black shale's the Genesis flood. We talked about what is shale, who cares? A lot of us care about the origin of black shales, right? 2 recent important findings: the mud rock revolution. Shales can be deposited rapidly. Number 2, they have been deposited rapidly. And then the black shale paradox means what? It means that this whole idea of anoxic conditions, to explain it, no. If you want to preserve organic matter, the obvious alternative is you have an influx of a lot of dead stuff coming in rapidly. If it's rapid enough, it will be deposited. You don't need this anoxic conditions, right? We focus on one interval, the Upper Devonian, Lower Mississippian, extraordinary deposit extends across all of North America. It cannot be explained by any kind of uniformitarian model at all. And we talked about black shales and the Genesis flood a little bit, and I even talked about exploitation of black shale. So that's what I've got to talk about with black shales and the Genesis flood. The flood happened, and it happened suddenly. It came on this earth suddenly, and like the Lord Jesus Christ said, as it was in the days of Noah, so shall it be when the Son of Man returns. Jesus believed in the global flood. Moses believed in the global flood. Peter believed in the global flood. Amos believed in the global flood. Throughout Scripture, it's all around, right?